Another great feature of Heli-Dyn is the fact that you can export the nonlinear models that you actually built in Heli-Dyn into other environments. And two built-in environments we are supporting is MATLAB and Simulink. And the other one would be to extract it as a C++ code to be used in Microsoft Visual Studio. So it's actually pretty straightforward. Let's say you build a model, you go to load presets, and let's say we want to load the default model with a stability augmentation system. What we do is we go and trim the vehicle. So let's say we are trimming it at a forward flight velocity of 0, which means it's in hover. So let's trim the aircraft. Takes a bit long here. And once we apply the simulation, the trim conditions into the simulation initial conditions, and we go back to simulation, we can export this nonlinear model as a C++ library, which can later be used in any C code that you write by yourself. Similarly, you can export this nonlinear helicopter model into the MATLAB Simulink environment, and you can use it independent from Heli-Dyn within Simulink. So you have all the features of MATLAB Simulink, and you can apply this to your nonlinear helicopter model that you just built. Well, the initial conditions of the model that you export will be the initial conditions that you set in the initial conditions tab. And since I just trimmed it and I set the initial conditions as my trim values, the exported model will have the trim values as its initial condition. So exporting a model is pretty simple. All you need to do is go to Heli-Dyn, go to the simulation tab, and select the appropriate environment you want to export the model to. So it's either a Microsoft Visual Studio C++ library, or it can also be a library that can be called in MATLAB and Simulink. So let's select MATLAB and Simulink and say export model, and you have this little window that basically tells you that the model export was successful, and that's it. So where's the model? The model would be in your documents library, wherever Heli-Dyn was installed. So you double click on Heli-Dyn and you go to the model export folder, and here it is. Okay, you take these three files and copy them into the directory where you want to run your Simulink code. So we kind of made the process a little easy by giving an example in the Heli-Dyn installation. So this is what we do. We select these three files. Let's say copy, and you go to MATLAB. Right? This is your MATLAB, and in MATLAB you need to, of course, say where your where the folder is, where your Simulink file will be. In this case, in Heli-Dyn, under code examples, we have two examples here, one for MATLAB, one for C++, and one for Simulink. Let's choose this one. Let's choose Simulink as our directory. And once I choose Simulink as a directory, this is now what you will see in that directory. Now, as an example, we already have some model outputted models in that directory, but let's paste the ones we just copied. We say paste, and would you like to replace them? Yes, I liked, and here it is. That's it. Now the example file is this one here. It's called DLL usage Simulink example. So you double click on that, and this is your example file you will find when you install Heli-Dyn. Now what you see here is you have the longitudinal cyclic input, the collective, the lateral, and the pedal input, and the time step. Now the time step is up to us. The delta t time step for integration can be adjusted also here in Simulink using this little box here. What we can also input to this model is wind. X, north, Y, east, and down. In those directions we can input wind. And we can also input external forces and external moments to the CG of this model. Now this becomes very, very handy if you want to build a component outside of Heli-Dyn, let's say in Simulink. Let's say you have built an additional wing and you want to include this in your Heli-Dyn model in Simulink. So all you need to do is you need to calculate the forces and moments that your model will produce, move them to the CG of that helicopter, and just input them here as external forces and moments. And this goes into the Heli-Dyn helicopter model. Now, what is in this model? Let's take a look. We have the controls, the time step, we have wind, we have external forces and moments, and we have a function. So if you go into the function, what you will see is that we are calling the function that which we called model, right? It's been called here in this line. And the output of this would be a lot of things. These are the inputs, and the output of these will be all the helicopter states. Everything we see in Heli-Dyn, all the variables we see in Heli-Dyn will be outputted as a large data set, which we call helicopter states. Now, the number which state belongs to, comes in which order, can of course be checked back in the help manual. Now, the output of this, as I said, is the helicopter states structure, and we are selecting some of them here. We selected number 15, 16, 17, 27, and so on and so forth. And for this example, we have phi, theta, psi, roll rate, pitch rate, yaw rate. And this would be your model. Now, if you want to, now remember, Heli-Dyn Plus has the trim values inside, which means the attitudes like theta and phi will be the trim values, and the velocities and acceleration and things like this will all be whatever the initial conditions were in Heli-Dyn are now in this model. Now, the only thing that we input to this system at the initial condition is the controls. So the controls, you have to make sure, if you want to run this whole thing in trim, you need to make sure that the longitudinal cyclic input, the initial input, is the trim value. Now if I put the trim values into these dialog boxes, then I would expect that everything on this side would represent a trim condition. So let's look at the longitudinal cyclic control and make sure that we actually have the trim conditions to put in. So all we need to do is we go to longitudinal cyclic, copy this part here, and we say copy, and then input them here as inputs, right? And say OK. So then I have the trim value as an input to Heli-Dyn. Let's check collective. Since this is an example here, we already inputted some of these numbers. The collective control is pretty much the trim value. So is the lateral input. Lateral input is also the trim value. And the pedal input is probably the same, would also be the trim input. Now what happens if you don't have the trim values here? Well, the result will be that the simulation will no more be would not start from a trim condition. Now I inputted here a little step input just to demonstrate our simulation. Let's say the step input is equal to 0. Okay, so if I would run this simulation, I would expect that the helicopter would basically stay in trim. So I have a 6-second simulation, and I would start my simulation. But there's one thing you might want to remember here, that the time step we are putting in here might not necessarily be the time step of the whole simulation, because MATLAB Simulink does its own time step, right? And the time step of MATLAB Simulink is in configuration parameters. So if you come here to this window, we are using an Euler integration with a fixed time step of 0.01. So these two should match, because the 0.01 is the time step that Heli-Dyn is using as a model, and this number is the time step that the whole simulation, the MATLAB Simulink environment is using, and they better should match, so we have a simulation that is compatible, right? In this example that we provide with MATLAB, with Heli-Dyn, has these functions already built in. I mean, these parameters, they are already set for you, so you don't really have to change. But in case you start a brand new simulation in Simulink, you got to make sure that the time step here, which is a fixed time step, matches with the fixed time step Euler integration 0.01 in MATLAB as well. So this is something you might want to be careful. So 6 seconds of simulation. I say start simulation, and boom, that's it. 6 seconds of simulation already done. So let's look at phi. Phi is pretty much 0, right? These are all degrees. Theta is 0. So we're pretty much in trim. Right? I'm sorry, it's at its trim value. Psi is 10 to the minus 4. It's almost 0. So we are in trim. So let's say we give a step input to the pedal. Let's say I give 3 degrees of input. I have to convert this to radians. Heli-Dyn is using radians as an input. Now let's say at 3 degrees of input to the pedal, at what time? At time equals 1 second. So this will be our input. Say okay, and let's say run. So that's it. So you can look at phi. Phi is, well, pretty small, less than 1 degrees. The theta response is also pretty small, but psi should be large. If you look at this, in 6 seconds we have a 30 degrees of turn in psi. So if you would look at yaw rate, this is what you would see for a step input in pedal. This would be your yaw rate. So what happened here? What happens here is we exported the model, the nonlinear model, with the blade elements, blade flappings, and fuselage and wing and horizontal tails. All this nonlinear model is exported in Heli-Dyn and is run independent from the Heli-Dyn environment. So using this, you can design controllers. You can trim this in Simulink again, right? We have we can find equilibrium points for this system. You can build your own components and add this to the helicopter, and you can run your full simulation if you don't want to be in the Heli-Dyn environment. Now, 2 things I would like to tell is that when I export a model, we have a little window here that says DLL export. Now this is also very important. Here I can select which components I would like to export, which components of my helicopter I would like to export. Let's say I have built a tail rotor model in Simulink, and I want to export a model without the tail rotor. So all I need to do is I remove that tick here on the tail rotor. I say export model, and that's it. Now the model that I've exported, which I will be seeing here, right? The models I have exported here will be the models without a tail rotor. Now, if I copy this over here, now into my Simulink library, this blue block will now be a helicopter with no tail rotor. Now, where will the tail rotor come from? Well, if you build a tail rotor in this in Simulink, you can input the effect of the tail rotor through the external forces and moments. Now, this becomes something we use very often in class, where I would usually tell my students to export a model without a main rotor. So it would have a helicopter with tail rotor, fuselage, landing gear, ground effect, horizontal tail, and so on and so forth, but no main rotor. So then I would ask them to build a main rotor model in Simulink and add them through the external forces and moments into this Heli-Dyn Plus block and look at the response. And in fact, if you build your own model, your main rotor model in Simulink, and you get some results, you could actually compare your results with results from Heli-Dyn itself, because Heli-Dyn can run all these models, right? You can run these models in Heli-Dyn with similar inputs you would have in MATLAB and Simulink. We can do the same thing in Heli-Dyn Plus, so you can compare what the Heli-Dyn Plus output would have been if you had included the main rotor. So this becomes again very handy if we want to build a model where some of the components are built in MATLAB and Simulink. So another thing we are trying to do here is we could actually extract a main rotor only. So if I would say export model, it would give me a model of the main rotor only. Now, if you had a main rotor by itself, and you would have a block for your main rotor, and then you would extract another model, another block of a whole helicopter, and if you would combine them in Simulink, you could actually build a coaxial helicopter, right? If you wanted to build a coaxial, you would probably remove the tail rotor, right? You would extract this model. This would be one block in Simulink, and then you would export a second model that will look like main rotor, and you would export this model. Now you would have two models to be called within two blocks in MATLAB and Simulink, and if you put the positions of these two rotors on top of each other, you would actually be building a coaxial. If you put them side by side, it would be a syncopter. If you would put them in a nice distance, you might even be able to build a tandem type of helicopter. Now, you might even extract 4 main rotors and add them in Heli-Dyn. Add them in MATLAB and Simulink in a certain geometric way, and maybe even build a quad rotor. And you would, in the main rotor model you would extract from Heli-Dyn Plus would still have the libraries behind this Heli-Dyn. You would still have Peter-Shah inflow models. You would still have the sophisticated codes that are embedded in this Heli-Dyn, and you can work absolutely independently in MATLAB and Simulink. And as I said, similarly, you can do this with C++. Let's say you built your own simulator and you need a library for C++. So you could do that as well, and you can call this as a DLL function call. Similarly, you can just make a function call and and get the main rotor from Heli-Dyn and maybe add some of the other stuff into your simulation. Now, you might have known that Heli-Dyn is the name of this program, but we have a little plus here. It's Heli-Dyn Plus. So Heli-Dyn Plus is the capability to export models. So if you just have Heli-Dyn, which is typically free, you stay in this environment, you stay in the Heli-Dyn environment. But if you want to take out the model and put it into Simulink, put it into your simulator, in your C code, and so on and so forth, for that you would need Heli-Dyn Plus. So that would be an extra feature that we're providing with this software. Well, thank you very much for listening and for your interest to Heli-Dyn Plus. Please send us an email or contact us for more information. We would be very happy to assist you. And I hope this will be a tool that can be used in a lot of modeling efforts and in a lot of work. So thanks again for listening.